OSHA requires that electrical equipment used in the workplace meet certain safety standards, which includes lighting equipment. A polarized plug has two blades of different widths. One blade is wider than the other. When plugged into a standard outlet, the wider blade connects to the neutral wire, which is not carrying current. The narrower blade connects to the hot wire, which carries the electricity. A GFCI, or ground fault circuit interrupter, is a type of electrical outlet that detects changes in the electrical current flowing through the circuit. If the current changes suddenly, such as when there is a ground fault, the GFCI trips and shuts off the power. Double insulation is a safety feature that provides protection from electrical shock. Double insulated equipment has two layers of non-conductive material between the live parts and the accessible surfaces. OSHA guidelines do not specifically require that temporary string lights have grounded plugs. However, they do require that all electrical equipment used in the workplace be protected from electrical shocks. This can be achieved by using polarized plugs in conjunction with GFCIs or by using double insulated equipment. If string lights have polarized plugs but it cannot be verified that they are double insulated, the safest course of action is to plug the lights into a GFCI. This provides protection from electrical shocks in the event of a ground fault. There isn't specific OSHA documentation that states that plugging polarized string lights into a GFCI will adhere to OSHA guidelines, but there is general guidance that requires electrical equipment to be protected from electrical shocks, and using polarized plugs with GFCIs is a recognized method of providing this protection. To elaborate further on polarized plugs, understand that the design ensures that electrical devices are connected to the power supply in the correct orientation. The wider neutral blade corresponds to the neutral wire in the outlet, which is typically at or near ground potential, meaning close to 0 volts. The narrower blade corresponds to the hot wire, which carries the 120 volts in a standard North American outlet. This polarization helps prevent electrical shock by ensuring that the device's internal circuitry is properly aligned with the power source. For example, in a lamp, the switch should be on the hot side so that when the lamp is switched off, the entire internal circuit is de-energized. If the plug were reversed, the switch would only interrupt the neutral side and the lamp socket would still be connected to the hot side, posing a potential shock hazard even when the lamp is switched off. Now let's dig deeper into ground fault circuit interrupters. A GFCI constantly monitors the current flowing into and out of a circuit. Under normal conditions, the current flowing through the hot wire should be equal to the current flowing back through the neutral wire. However, if a ground fault occurs, such as when a person touches a live wire or when there's a short circuit to ground, some of the current will flow through an unintended path, like the person's body or the ground wire. This creates an imbalance between the incoming and outgoing current. The GFCI is designed to detect even very small imbalances, typically in the range of 4 to 6 milliamps or 4 to 6 amps. When an imbalance is detected, the GFCI trips and shuts off the power to the circuit within a fraction of a second, often as quickly as 25 milliseconds or 25 seconds. This rapid response time is crucial to prevent serious electrical shock or electrocution. GFCIs are commonly found in areas where there is a high risk of water exposure, such as bathrooms, kitchens, laundry rooms, and outdoor outlets. They are also used in construction sites and other workplaces where electrical equipment is used in damp or wet conditions. Now let's consider double insulation. Double insulation is a design technique used to protect against electrical shock by providing two independent layers of insulation between the live parts of an electrical device and the user. This means that if one layer of insulation fails, the second layer will still provide adequate protection. Double insulated devices are typically identified by a symbol consisting of a square inside another square. These devices do not require a ground connection because the double insulation provides sufficient protection against electric shock. The two layers of insulation are typically made of non-conductive materials such as plastic or rubber. The first layer of insulation, called functional insulation, insulates the live parts of the device from the internal components. The second layer of insulation, called protective insulation, insulates the internal components from the outer casing of the device. This ensures that even if the functional insulation fails, the user is still protected from electric shock. Double insulated tools and appliances are commonly used in situations where a ground connection is not available or is not practical, such as when working outdoors or in older buildings with ungrounded electrical systems. Now, to tie it all together, OSHA's electrical safety standards are primarily found in Title 29 of the Code of Federal Regulations, or CFR, Part 1910.301 through 1910.399, often referred to as Subpart S. These regulations cover a wide range of electrical safety requirements for general industry. While OSHA does not explicitly state that using polarized plugs with GFCIs is a definitive method of compliance for temporary string lights, the agency emphasizes the importance of protecting employees from electrical hazards. Section 1910.303 requires that electrical equipment be free from recognized hazards that are likely to cause death or serious physical harm to employees. Section 1910.304 addresses the use of extension cords and flexible cords, stating that they must be protected from accidental damage and that portable equipment must be grounded or double insulated. When using temporary lighting, particularly string lights, it's crucial to ensure that the equipment is suitable for the intended environment. If the lights are used in damp or wet locations, they should be specifically designed for such use and marked accordingly. In the absence of clear documentation regarding double insulation, using GFCIs provides an additional layer of protection against ground faults. The GFCI will quickly energize the circuit if a fault is detected, reducing the risk of electrical shock. Furthermore, regular inspection of electrical equipment, including string lights, is essential to identify any signs of damage or wear. Damaged cords, cracked housings, or loose connections should be promptly repaired or replaced to prevent electrical hazards. In summary, while specific OSHA documentation may not explicitly mandate the use of GFCIs with polarized string lights, the general requirements for electrical safety and the need to protect employees from electrical hazards make the combination of polarized plugs and GFCIs a prudent and widely accepted practice. It's important to prioritize safety and follow established guidelines to minimize the risk of electrical accidents in the workplace. Let's delve into more details concerning the practical application of these safety measures. When installing temporary string lights, several factors should be considered to ensure safety and compliance. Firstly, the lights should be installed in a manner that prevents them from being subjected to physical damage. This may involve using appropriate supports or strain relief to prevent the cords from being stretched or pinched. Secondly, the lights should be positioned so that they do not create a tripping hazard or obstruct walkways. This is particularly important in areas with heavy foot traffic. Thirdly, the lights should be inspected regularly for any signs of damage, such as frayed cords, cracked sockets, or loose connections. Any damaged light should be immediately removed from service and either repaired or replaced. In addition to these practical considerations, it's also important to educate employees about the proper use of temporary lighting and the potential hazards associated with electricity. Employees should be trained to recognize the signs of electrical hazards and to report any concerns to their supervisor. They should also be instructed on the proper use of GFCIs and the importance of testing them regularly to ensure that they are functioning correctly. Now let's consider some specific scenarios where the use of GFCIs is particularly important. One such scenario is when temporary lighting is used in damp or wet locations, such as outdoor construction sites or indoor areas where water may be present. In these situations, the risk of electrical shock is significantly increased, and the use of GFCIs is essential to protect workers from potential hazards. Another scenario is when temporary lighting is used in areas where metal objects are present, such as metal scaffolding or metal containers. In these situations, the risk of a ground fault is increased, as a live wire may come into contact with the metal object, creating a potential shock hazard. Again, the use of GFCIs is essential to quickly de-energize the circuit and prevent electrical shock. It's also worth noting that some jurisdictions may have specific regulations regarding the use of temporary lighting and GFCIs. These regulations may require the use of GFCIs in certain situations or may specify the types of temporary lighting that are permitted. It's important to be aware of these regulations and to ensure that all temporary lighting installations comply with them. To further illustrate the importance of GFCIs, consider a scenario where a worker is using a power tool connected to a temporary string light. If the power tool has a faulty cord or a damaged internal component, it may develop a ground fault, causing current to flow through the worker's body to ground. Without a GFCI, the worker could receive a serious or even fatal electrical shock. However, if the string light is protected by a GFCI, the GFCI will quickly detect the ground fault and energize the circuit, preventing the worker from being injured. The GFCI acts as a safety net, providing an additional layer of protection against electrical hazards. In addition to using GFCIs, it's also important to ensure that all temporary lighting equipment is properly maintained and inspected. This includes checking the cords for any signs of damage, such as cuts, abrasions, or fraying. It also includes checking the sockets for any cracks or loose connections. Any damaged equipment should be immediately removed from service and either repaired or replaced. Regular maintenance and inspection can help to identify potential hazards before they cause an accident. Another important aspect of electrical safety is the proper use of extension cords. Extension cords should be used only for temporary applications and should not be used as a substitute for permanent wiring. They should be sized appropriately for the equipment being powered and should not be overloaded. Overloading an extension cord can cause it to overheat, which can lead to a fire. Extension cords should also be protected from physical damage, such as being pinched by furniture or run over by vehicles. Damaged extension cords should be immediately removed from service and either repaired or replaced. In addition to these practical measures, it's also important to promote a culture of safety in the workplace. This involves encouraging employees to report any safety concerns to their supervisor and providing them with the necessary training and resources to work safely. It also involves conducting regular safety meetings and inspections to identify and address potential hazards. By creating a culture of safety, organizations can reduce the risk of electrical accidents and create a safer working environment for their employees. Let's not forget about the importance of proper grounding. While double-insulated tools do not require grounding, other electrical equipment should be properly grounded to provide a safe path for fault current to flow back to the source. Grounding helps to prevent electrical shock by ensuring that metal parts of equipment are at or near ground potential. The grounding system should be regularly inspected to ensure that it is functioning correctly. This includes checking the grounding conductors for continuity and the grounding electrodes for proper installation. A properly grounded electrical system is an essential component of electrical safety. Now, to provide additional clarity, let's address some common misconceptions about GFCIs. One common misconception is that GFCIs protect against all types of electrical shock. In reality, GFCIs only protect against ground faults, which occur when current flows through an unintended path to ground. GFCIs do not protect against shocks that occur when a person comes into contact with both the hot and neutral wires of a circuit. Another common misconception is that GFCIs are foolproof and never fail. While GFCIs are highly reliable, they can fail due to various factors such as age, wear, or electrical surges. It's important to test GFCIs regularly to ensure that they are functioning correctly. A third common misconception is that GFCIs are only needed in wet locations. While GFCIs are particularly important in wet locations, they can also provide valuable protection in dry locations where there is a risk of ground faults. In summary, GFCIs are an important safety device that can help to prevent electrical shock. However, they are not a substitute for other safety measures such as proper grounding and regular equipment inspection. It's important to understand the limitations of GFCIs and to use them in conjunction with other safety practices to create a safe working environment. Let's shift our attention to the selection of appropriate temporary lighting equipment. When selecting temporary lighting, it's important to choose equipment that is designed for the intended environment. For example, If the lighting will be used in a wet location, it should be specifically designed for wet locations and marked accordingly. The lighting should also be durable enough to withstand the rigors of the workplace. This may involve choosing lighting with a rugged housing and a heavy-duty cord. The lighting should also be energy efficient to minimize energy consumption and reduce operating costs. LED lighting is a good option for temporary lighting as it is both energy efficient and long-lasting. When selecting temporary lighting, it's also important to consider the light output required for the task. The light output should be sufficient to provide adequate illumination for the work being performed. Insufficient lighting can lead to eye strain, fatigue, and accidents. The light output should also be evenly distributed to avoid shadows and glare. In addition to these technical considerations, it's also important to consider the cost of the lighting. The cost should be balanced against the performance and durability of the lighting. It's often worth investing in higher quality lighting that will last longer and provide better performance. In conclusion, the selection of appropriate temporary lighting equipment is an important aspect of electrical safety. It's important to choose equipment that is designed for the intended environment, durable enough to withstand the rigors of the workplace, and energy efficient. The light output should be sufficient to provide adequate illumination for the work being performed. The cost should be balanced against the performance and durability of the lighting. Now, let's discuss the importance of regular safety training. Safety training is an essential component of any electrical safety program. It helps to ensure that employees are aware of the potential hazards associated with electricity and that they know how to work safely. Safety training should cover a wide range of topics, including the proper use of electrical equipment, the identification of electrical hazards, and the procedures for responding to electrical emergencies. Safety training should be conducted regularly to reinforce safe work practices and to keep employees up to date on the latest safety information. Safety training should also be tailored to the specific needs of the workplace. For example, employees who work with high-voltage equipment may require more specialized training than employees who work with low-voltage equipment. Safety training should be interactive and engaging to keep employees interested and motivated. It should also include hands-on exercises to allow employees to practice safe work procedures. Safety training should be documented to provide a record of the training that has been conducted. This documentation can be used to demonstrate compliance with OSHA regulations. In addition to formal safety training, it's also important to provide employees with ongoing safety reminders and tips. This can be done through safety posters, toolbox talks, and other communication channels. By providing regular safety reminders, organizations can help to keep safety top of mind for their employees. Safety training is an investment that can pay off in the form of reduced accidents, improved productivity, and a safer working environment. It's an essential component of any successful electrical safety program.